Welcome. I'm so glad you found your way here to this quiet corner of the world. Take a moment to just be. Let the day's thoughts start to soften, like ink dissolving in water. Tonight, we're going to explore something truly remarkable, but we're going to do it with a sense of peace and wonder. We are entering the realm of the quantum, a word that sounds like a heavy door, but it's actually a gateway to a world that is light, airy, and incredibly small. Think about the room around you, the way the light catches the corner of a picture frame, or the way your blanket feels heavy and warm. Everything feels so solid, doesn't it? The chair, the floor, the glass of water. But tonight, we're going to look closer. Imagine if you could shrink down, becoming smaller than a grain of sand, smaller than a speck of dust, smaller than even a single cell. As we move deeper into the fabric of reality, the things we thought were solid begin to change. In the macro world, the world of the big, we understand how things work. If you drop a ball, it falls. If you push a door, it opens. But as we travel down into the heart of the very small, we find a place where the universe behaves differently. This is the quantum world. It is the hidden foundation of everything. It's a place where things can be in two places at once, and where particles whisper to each other across the void. It's a strange and beautiful truth that everything we can see, every mountain, every ocean, every person you've ever loved, is built entirely from things we cannot see. We are like people looking at a magnificent tapestry from a distance. We see the beautiful patterns and the vibrant colors. But tonight, we are going to lean in close until we can see the individual threads. And then, we will look closer still, until we see the fibers that make the threads. And finally, we will find the quiet energy that makes the fibers.
There is something very comforting about this. It means that even in the stillness of your room, there is a magnificent, intricate dance happening all around you, and even inside you. You are a collection of these tiny wonders, perfectly balanced, perfectly held together by forces that have existed since the beginning of time. As you settle into your blankets, just let that thought carry you. You are part of a vast, invisible harmony. Everything is exactly where it needs to be. The universe is quiet, and so are we. Let's begin our journey into the small, one gentle step at a time. As we begin this journey together, I want you to take a moment to truly settle into the space around you. If you need to adjust your pillow once more, or perhaps pull the covers up to your chin to find that perfect, cozy weight, please do so now. Let your shoulders drop away from your ears. Let the muscles in your face soften, starting with your forehead, then your jaw, until you feel a gentle heaviness in your limbs. There is a profound peace in knowing that for the next while, your only task is to listen. If these quiet stories of the universe help you find your way to sleep, you might consider subscribing to the channel or leaving a soft like on this video. It is a small gesture, but it helps our quiet community grow and ensures that these peaceful explorations will always be here to guide you into rest. But for now, don't worry about the screen or the world outside. Just let the sound of my voice be a soft tether as we drift further into the mystery of the small. Let's take one slow, intentional breath together. Breathe in the stillness of the room and let out a long,
quiet sigh. Feel the way your body sinks just a little deeper into the mattress.
Now, as we leave the world of the big behind, let's consider the very first thing that ever gave us a hint that the universe wasn't quite what it seemed. Let's think about light. Light is perhaps the most familiar thing in our lives. It's the warm glow of a bedside lamp, the pale silver of the moon, the first golden threads of a sunrise. We live our lives bathed in it, yet for centuries, light was the greatest puzzle in all of science. It was a riddle that the smartest minds in history couldn't quite solve using the regular rules of the world. Think back to the scientists of the past, sitting by candlelight, trying to understand the nature of a beam of light. Some, like Isaac Newton, believed light was made of corpuscles, tiny solid little pebbles of matter that traveled in straight lines. It made sense to them. After all, light bounces off a mirror just like a ball bounces off a wall. But other scientists looked at the way light ripples and bends, the way it creates rainbows in a spray of water, and they insisted that light must be a wave, like a vibration moving through a quiet pond. This debate went on for hundreds of years. Was light a particle, or was it a wave? It couldn't be both, could it? In the world we see with our eyes, things are usually one or the other. A rock is a rock, and a ripple is a ripple. But as scientists looked closer and closer at the nature of light, the old rules began to crumble. They found themselves standing at the edge of a vast, unknown territory. It was this very confusion, this beautiful, shimmering mystery of light, that eventually gave birth to quantum physics. It was the first time we realized that when you look at the very small, the logic of the everyday world no longer applies. Light was our first messenger from the quantum realm, whispering to us that at the heart of reality, things are far more fluid and magical than we ever dared to dream. And so, as you rest there in the darkness, remember that even the shadows are made of this same mysterious light, waiting quietly to reveal its secrets to us as we drift further into the night. As you lie there, perhaps wondering about these mysterious messages from the light, there is a single word that often feels heavy or complicated. It is a word we hear in movies and in science books, one that often feels like it belongs only to the most brilliant minds. That word is quantum. But when we strip away the complex math and the difficult theories, the word itself has a very humble and simple beginning. If you can, imagine the word quantum not as a daunting scientific term, but as a soft, curious question. It comes from the Latin word quantus, which simply means how much. It was a way for early scientists to ask a very basic question about the world. How much energy is actually there? For a long time, we believed that the universe was a smooth and continuous place. We thought of energy, like the warmth of a sunbeam or the sound of a distant lullaby, as a steady, flowing stream. Imagine for a moment a river flowing past you in the quiet of the night. To your eyes, it looks like one long, unbroken ribbon of silver. It seems as though you could take a tiny sip or a large gulp, and that you could divide that water into any amount you wanted, no matter how small. In our everyday lives, things seem to flow into one another without any gaps. When you turn a dimmer switch, the light seems to fade perfectly and smoothly into the shadows. When you slow down your walk, your speed seems to decrease in one fluid motion. But the quantum world tells us a different story. It tells us that if you could look closely enough, closer than any human eye or even the most powerful microscope could ever see, the river of energy isn't a smooth ribbon at all. Instead, it is made of tiny individual drops. This is the heart of what quantum really means. It is the discovery that nature doesn't move in a perfectly smooth, endless line. Instead, it moves in little bundles. These bundles are called quanta. You can think of them as the universe's smallest possible packets of stuff. Imagine you are pouring a bowl of very fine golden sand. From a distance, the sand looks like a liquid flowing softly through your fingers in a single golden stream. But as you bring your eyes closer, you see that the stream is actually made of thousands of tiny, distinct grains. You can have one grain of sand, or two, or three, but you can never have half a grain. The grain is the quantum of the sand pile. It is the smallest unit you can have while it still remains sand. This might seem like a small detail, a minor correction to how we see the world. But this realization, that energy comes in fixed, discrete amounts rather than a continuous flow, was the key that unlocked a door we didn't even know existed. It was the first step into a reality that is much more organized and granular than we ever suspected. It means that at the very deepest level, the universe is built out of these tiny, discrete heartbeats of energy. Nothing is truly blurry when you get down to the very bottom of it. It is all organized into these neat, quiet little packages. This discovery changed everything we thought we knew about the fabric of reality. It suggested that the universe has a limit to how small things can get, and that energy moves in specific, countable steps. As you rest there, let that thought settle into your mind. The world around you, the bed beneath you, and the very air you breathe are all supported by these tiny, invisible packets. Everything is held together by a hidden structure, a rhythmic counting of energy that keeps the universe stable and constant. It is a comforting thought to know that even in the vastness of space and the complexity of life, there is a fundamental order, a series of small, perfect units that make up everything we see and feel. We are drifting now into a world where these little packets of energy begin to reveal their strange and beautiful patterns. To help visualize this, imagine you're standing at the base of a long, sturdy wooden ladder that stretches up into a soft, evening mist. In our everyday world, the world of mountains, cars, and ocean waves, we are used to things being like a smooth, sloping ramp. If you walk up a ramp, you can stop at any point you like. You can move forward an inch or a centimeter, or even the tiniest fraction of a hair's width, and you will still be standing on solid ground. In this classical view of the world, energy is a continuous slope where every possible height is available to you. But as we move into the quiet realm of the very small, the ramp disappears. In its place, we find the ladder. This is one of the most fundamental truths of quantum physics, and it changes everything about how we perceive the fabric of nature. When we look at an atom, we see that the electrons, those tiny, energetic particles that circle the nucleus, behave like climbers on this ladder. An electron can sit comfortably on the first rung, or it can jump up to the second, or the third. But it can never, ever exist in the space between the rungs. Imagine trying to stand in the empty air halfway between two steps on a staircase. In our world, you would simply fall. But in the quantum world, it is physically impossible to even be in that gap. The space between the steps is a forbidden zone,
There is no such thing as halfway between energy levels.
This means that when an electron moves from one level to another, it doesn't travel across the gap in the way we understand movement. It doesn't slide through the air or pass through the intervening space. Instead, it is on one rung, and then, in a single instantaneous heartbeat, it is on the next. This is the true meaning of a quantum leap. It is a sudden, discrete change from one state to another, with no middle ground and no time spent in between. It might sound strange, perhaps even a bit like a dream, but this ladder-like structure is what gives our universe its incredible stability. If electrons were on a smooth ramp, they could slowly lose energy and slide down toward the center of the atom, eventually spiraling inward until the atom collapsed. But because they are forced to stay on their specific rungs, they stay in their proper places. Atoms stay open, they stay structured, and they keep their shape. This is why the world around you feels solid and reliable. It is why the bed beneath you holds its form, and why the air remains a gas rather than collapsing into nothingness. The ladder ensures that energy isn't just a chaotic, messy flow. It is organized, rhythmic, and follows a set of quiet, invisible rules. As you rest there, you can imagine the trillions of atoms that make up your own body, each one a tiny system of ladders and steps. Within you, millions of electrons are resting on their assigned rungs, perfectly balanced and perfectly still. There is no effort required to maintain this order. It is simply the way the universe is built, a hidden architecture of peace and precision that supports you in every moment. This shift in our understanding, moving from the idea of a smooth, endless ramp to a world of structured individual steps, was the great turning point for science. It forced us to rethink the very meaning of how much energy exists in a single moment. It was a discovery that didn't happen all at once, but began with a few quiet thinkers who looked at the simple things, like the warm, red glow of a heating element or the light of a distant star, and realized that the math of the old world could no longer explain the beauty of the new one. To understand how we discovered this hidden ladder of energy, we have to look back at a quiet, thoughtful man named Max Planck. He is often called the father of quantum theory, though he didn't set out to start a revolution. He was simply a scientist who loved order and logic, and he wanted to solve a very specific, very gentle puzzle. He wanted to understand the warm glow of heat. Think for a moment about a piece of iron being heated in a fire, or even the glowing coils of a toaster in a quiet kitchen. As the metal gets hotter, its color begins to change. First, it gives off a deep, dull red. As the temperature rises, that red turns into a bright orange, then a brilliant yellow, and eventually, if it gets hot enough, it glows with a pure, steady white light. Scientists at the time called this black body radiation. They knew there was a relationship between the temperature of an object and the color of the light it produced. But when they tried to use the old rules of physics to explain it, the math simply didn't work. According to the old laws, which treated energy like a smooth, endless wave, an object should technically give off more and more high-energy light as it gets hotter, spiraling into the invisible parts of the spectrum. But that isn't what happens in our world. A warm cup of tea doesn't emit dangerous rays. It just glows with a soft, invisible infrared warmth that you can feel on your skin. There was a mismatch between what the eyes saw and what the science books predicted. In the final weeks of the year 1900, Max Planck was working in his study, surrounded by the quiet of the evening. He realized that the only way to make the mathematics of heat match the reality of that warm red glow was to make a daring assumption. He proposed that energy isn't like water flowing through a pipe, which can be measured in any tiny, infinite amount. Instead, he suggested that energy is more like sand. From a distance, a sand dune looks smooth and continuous, but when you run your fingers through it, you realize it is made of individual, distinct grains. Planck discovered that energy is granular. It comes in little packets. He called these packets quanta, from the Latin word for how much. This was the moment the quantum world was born. It was the realization that the universe doesn't deal in infinitely small fractions. It deals in specific, countable units. To make this discovery official, Planck identified a very special number that governed the size of these energy packets. In the history of science, this is known as Planck's constant, represented by the simple letter h. It is a fundamental constant of nature, like the speed of light. It is an incredibly tiny number, so small that we never notice it in our daily lives. It is a decimal point followed by 33 zeros before you reach the first digit. It is the signature of the very small. This discovery changed everything. It meant that the warm glow of a fire or the soft light of a lamp is actually a rain of countless tiny energy packets, falling so fast and so thick that they look like a continuous stream. As you rest now, you can imagine the warmth of your own room as a gentle, invisible mist of these grains, each one carrying a tiny, specific amount of energy, perfectly regulated by the laws Planck uncovered. By finding the H at the heart of the universe, Planck opened a door that could never be closed again. He showed us that the world is not a blurry, messy place, but a collection of precise, rhythmic units. This quiet German physicist provided the map for the next great mind to step forward. A young man who would take Planck's mathematical packets and show us that they weren't just a clever trick of the math, but a physical reality that we could see and touch. While Max Planck had found the mathematical key to the universe's energy packets, it was a young patent clerk named Albert Einstein who gave those packets a physical form. In 1905, during a year of incredible creative insight, Einstein took Planck's abstract numbers and turned them into something we could almost touch, something he visualized as tiny, discrete bundles of light. Imagine you are standing by a calm, still pond at night. In the old way of thinking, light was like a ripple on that pond, a smooth, continuous wave spreading out across the water. But Einstein suggested something different. He asked us to imagine that light is actually made of magic pebbles, tiny, individual particles of energy that travel through the dark. This idea came from a strange observation called the photoelectric effect. Scientists had noticed that when light shines onto a metal surface, it can sometimes knock electrons, the tiny components of atoms, right off the metal, like dust being blown away by a breeze. But the way it happened was a profound mystery. If you shone a very bright, intense red light on the metal, nothing would happen. No matter how long you waited or how bright you made that red glow, the electrons stayed put. Yet, if you shone even a very faint, dim violet light on the metal, the electrons would instantly go flying off. Einstein realized that this only made sense if light was made of individual particles, which we now call photons. Think of each photon as a single pebble. A red light photon is like a soft, light pebble. It doesn't have enough energy to nudge an electron, no matter how many of them you throw at the metal. But a violet light photon is like a heavy, energetic stone. Even a single one has enough strength to knock an electron free. This was the physical proof of Planck's quanta. Light wasn't just a fuzzy, continuous wave. It was a stream of distinct, energetic units. Each little pebble of light carried a specific paycheck of energy. If the paycheck was large enough, the electron could afford to leave the metal. If it wasn't, no amount of light would help. It is a common misconception that Albert Einstein received his Nobel Prize for his famous theory of relativity, or the equation E equals mc squared.
In reality, it was this work, his explanation of the photoelectric effect, that earned him the world's most prestigious scientific honor. He had looked at the very nature of light and seen something no one else had, a universe built of tiny individual parts working in perfect, quiet harmony. As you lie there, perhaps you can imagine the light in your own life, the soft glow of a distant street lamp or the pale moonlight through a window, not as a solid beam, but as a gentle rain of these magic pebbles. They are falling silently, billions of them every second, each one carrying its own little spark of energy, keeping the world in motion while you remain perfectly still. This discovery was a bridge. It connected the old world of waves to the new world of particles, leading us toward an even deeper mystery, the realization that light might not be just one thing, but two.
This brings us to a question that kept the greatest minds of the 20th century awake at night, though for us it is merely a gentle thought to carry into sleep. If light is made of these tiny magic pebbles, these photons that Einstein described, then what happened to the waves? Before Einstein, scientists were certain light was a wave, like a ripple in a pond or a soft vibration in the air. They had seen it bend around corners and overlap like the delicate patterns on a butterfly's wing. So, which is it? Is light a particle, or is it a wave? The answer, as strange as it may seem, is simply yes. It is both. In our everyday world, the world of houses and trees and heavy blankets, things usually choose a side. A baseball is a particle. It is a solid object you can hold in your hand. A sound is a wave. It is a vibration that travels through the air. We do not usually see things acting as both at the same time. But as we drift deeper into the subatomic realm, the rules we use for baseballs and sound waves begin to soften and blur. This is the concept of wave-particle duality. It is perhaps the most famous cornerstone of quantum physics, and it invites us to accept a reality that is far more flexible than it appears. Imagine for a moment an object that looks like a circle when you view it from the front, but like a rectangle when you view it from the side, much like a simple wooden cylinder. If you only ever looked at the front, you would be certain the object was a circle. If you only looked at the side, you would be convinced it was a rectangle. Light is a bit like that cylinder. It has a nature that is deeper and more complex than a single label can describe. It is not that light changes what it is, but rather that we only see one aspect of it at a time. When light travels through the vast, empty reaches of space, it behaves like a gentle, rhythmic wave, spreading out and flowing through the dark. But the moment it strikes a surface, like the back of your eye or a leaf in the garden, It gathers itself together and acts like a particle, delivering its energy in one specific spot. It is as if light is a shapeshifter, choosing its form based on how it interacts with the world. There is something deeply peaceful about this. It suggests that the universe doesn't have to be just one thing. It can be many things at once, holding different truths in a quiet, steady balance. You do not need to choose between the pebble and the ripple. You can simply exist in the space where they meet. As you settle further into your blankets, let the strange logic of the subatomic world wash over you. In the quantum world, either/or is replaced by both/and. This duality isn't a conflict, it is a harmony. It is a fundamental property of every single thing you see. Not just light, but the very electrons that make up your body, the air you breathe, and the bed beneath you. Everything has a wave nature and a particle nature, a soft vibration and a solid presence. We are beginning to see that the universe is not just a collection of hard, cold facts, but a series of relationships and perspectives. The way we look at the world changes what we see. And as we prepare to look closer at the wave side of this mystery, we can imagine the surface of a still, dark lake at midnight, waiting for the first tiny ripple to move across the water. Close your eyes once more and return to that image of the dark, still lake. It is a perfect mirror of the night sky, reflecting the distant, silent stars in its deep, cool waters. Imagine a single drop of water falling from a leaf above, striking the center of the pool with a soft, liquid sound. A tiny ripple begins to spread outward in a perfect, expanding circle. It moves slowly, rhythmically, carrying energy across the surface. This is the essence of a wave, a pattern of movement that travels through a medium, a gentle pulse that shares its presence with everything it touches. Now, imagine a second drop falls just a few inches away. It too creates its own set of ripples, expanding outward in every direction. As these two circles of energy grow, they eventually find one another. This is where the quiet magic of waves reveals itself. Unlike solid objects, which would bounce or collide, these ripples simply pass through one another. But in the brief moments where they overlap, they engage in a beautiful, silent dance. If the peak of one ripple meets the peak of another, they join forces. They lift the water higher together, creating a single, stronger wave. Scientists call this constructive interference, a moment where two separate things combine to become something greater. It is a reinforcement, a gentle surge of collective energy. But there is a second possibility, one that is perhaps even more mysterious. If the high peak of one wave meets the low valley of another, they perfectly balance each other out. For a fleeting second, the water becomes perfectly flat and still again. The waves have not disappeared, they have simply canceled each other out through their own geometry. This graceful interaction, this ability to add together or subtract, is the defining signature of a wave. And as we drift deeper into the night, we can see that light follows these exact same rules. Light is not just a steady glow, it is a series of these invisible ripples moving through the fabric of the universe. When light waves overlap in just the right way, they create patterns of strength and silence. They create bright spots where the peaks meet, and dark spots where the peak of one wave fills the valley of another. It is a fundamental truth of our reality. Light waves can cancel each other out or make each other stronger. Take a slow, deep breath. Feel the rise and fall of your own breath, a rhythmic wave of its own, keeping you anchored and safe. There is no need to solve the puzzles of physics tonight. You can simply let the image of the overlapping ripples float in your mind, like shadows moving across a wall. The universe is a vast tapestry of these invisible overlaps, where energy meets, blends, and transforms in a constant, quiet harmony. In the early days of science, researchers wanted to witness this wave nature of light with absolute certainty. They wanted to see the interference with their own eyes, to prove that light was a flowing, rhythmic field rather than a hail of tiny particles. They devised a simple but profound test, a way to force light to reveal its true character. They took a dark room and placed a screen in front of a light source. But this screen had two very thin, parallel slits cut into it, like two narrow gates standing side by side. They wanted to see what would happen when the light passed through both openings at once. Imagine that light now, beginning its journey in the darkness. It moves toward those two small openings like water flowing toward a pair of gates in a stone wall. It is a journey of curiosity, leading us toward an experiment that would eventually challenge everything we thought we knew about the world. For now, just see the light approaching the gates, steady and calm, ready to reveal the secrets of the very small. We have arrived at the threshold of what many consider the most beautiful, yet most perplexing experiment in all of science. It is known simply as the double-slit experiment, and it is the gateway through which we must pass to truly understand the dreamlike nature of the quantum world. Imagine yourself standing in a very large, very dark room. The air is cool and still, and there is a profound silence that feels like a heavy, soft blanket. In front of you, there is a barrier with two thin, vertical openings, two narrow slits that allow only the smallest sliver of light or matter to pass through. Behind this barrier, a short distance away, is a back wall or a screen, ready to record whatever manages to make it through those two gates. In our everyday world, the world of heavy objects and solid surfaces, we know exactly what to expect. If you were to stand in the dark and toss small, glowing marbles at that barrier, most of them would simply bounce off the solid parts of the wall and fall away into the shadows. Only a few would happen to fly through the two slits. If you did this for hours, tossing marble after marble, you would eventually look at the back wall and see two distinct vertical lines of light, matching the shapes of the two slits. It is logical. It is predictable. It is the way we expect a solid world to behave. One marble goes through one hole and hits one spot. It is a simple story of cause and effect, as steady and reliable as the ticking of a grandfather clock in a quiet hallway. But as we move into the realm of the incredibly small, the story begins to change, shifting into something much more fluid and mysterious. When scientists first performed this experiment using light, they didn't see two simple lines on the back wall. Instead, they saw a beautiful, shimmering pattern of many lines, bright bands of light separated by dark bands of shadow. It looked like a barcode of glowing energy, spreading out far wider than the two slits themselves. This was the interference pattern we spoke of earlier. the signature of waves. As the light passed through the two slits, it fanned out like ripples from two stones dropped into a pond. Where the peaks of those ripples met, they created a bright stripe. Where a peak met a valley, they canceled out, leaving a stripe of darkness. This confirmed that light, in its travels, behaves like a gentle, rhythmic wave. However, the true mystery, the moment where the floor of reality seems to soften beneath our feet, occurred when scientists began to use matter instead of light. They took electrons, the tiny, solid-seeming particles that orbit the centers of atoms, and they fired them at the two slits. At first, they thought the electrons would act like the marbles, piling up in two neat rows. But the universe had a different plan. Even when they slowed the experiment down, firing the electrons one by one, a strange thing began to happen. Each individual electron would pass through the barrier and strike the back wall as a single, tiny dot, just like a particle. But as more and more electrons were fired, one after another, a pattern slowly began to emerge from the individual dots. They weren't forming two lines. They were forming the same interference pattern as the light waves. Each electron, though it seemed to be a single point of matter, was contributing to a wave-like design. This means that even though the electrons were sent through one at a time, they were somehow interfering with themselves. It is as if each electron, in its quiet journey through the dark, didn't choose just one slit. It behaved as a wave of possibility, passing through both slits simultaneously, overlapping with itself and deciding where to land based on the math of ripples in water. When not observed, single electrons create an interference pattern like waves, defying our common sense and suggesting that, at its most basic level, matter is not a collection of solid points, but a series of overlapping waves of potential. As you lie there, perfectly still, consider the strange grace of this discovery. The very building blocks of your body, the electrons within your cells, possess this same hidden, wave-like nature, a quiet, shimmering duality that exists even in the deepest silence of the night. But as strange as it is to think of a single electron passing through two doors at once, the universe held an even more startling secret for the scientists watching in the dark. You see, curiosity is a natural human trait, and those researchers wanted to understand exactly how the electron managed this feat. They decided to place a detector at the slits, a tiny, quiet, watchful device designed to see which path the electron actually chose. They wanted to catch it in the act of being in two places at once, to see the magic as it happened. Imagine the scene. The room is silent. The machine is humming with a very low, steady vibration. The detector is ready, waiting to click or glow the moment an electron passes by its lens. But as soon as the scientists turned that detector on, as soon as there was a way to know for certain which slit the electron traveled through, the universe reacted in a way no one expected. The beautiful, shimmering interference pattern, those bands of light and shadow that looked like ripples on a pond, simply vanished. The electrons stopped behaving like waves. They stopped interfering with themselves. Instead, they began to act exactly like the solid little marbles we imagined at the very beginning. They passed through one slit or the other, landing on the back wall in two simple, straight lines. The moment the electron was watched, it seemed to lose its ghostly ability to be in two places at once. It chose a single path. It became a solid, definite thing. This is what physicists call the collapse of the wave function. It is the idea that before we look at it, a particle is a cloud of possibilities, a wave of maybe and perhaps spreading out through space. But the very act of measurement, the simple process of looking or detecting, forces the particle to make a choice. It collapses from a wide flowing wave into a single, localized point. It is as if the universe is a shy performer who dances with infinite grace when the stage is dark. But the moment the spotlight hits, it stops and stands perfectly still, pretending to be nothing more than a simple prop. This realization changed everything we thought we knew about the physical world. It suggests that the universe is not a clockwork machine running independently of us, but a place that reacts to being seen. The mere act of observation is a physical interaction. To see something, we must interact with it, even if that interaction is as light as a single photon of light bouncing off a surface. In the quantum world, you cannot observe something without changing it. The watcher is always part of the story. As you lie there in the soft darkness of your own room, you might find it comforting to think that the world is more flexible than it seems. When we aren't looking, when the lights are low and our eyes are closed, the world around us returns to that state of quiet, waving possibility. The rigid edges of reality soften. The atoms in your pillow, the air in the room, and the very cells of your body exist in a state of hidden, rhythmic potential, waiting for the morning light to call them back into their solid forms. This mystery, the way the universe settles into a single state only when we ask it a question, is one of the most profound truths ever discovered. It reminds us that there is a deep, fundamental difference between the world as it is when we are busy observing it, and the world as it is in the pure, undisturbed silence of the night. For now, you don't need to watch or measure anything. You can simply let the wave-like nature of the world carry you along, knowing that for this moment, you are part of a vast, unobserved sea of possibility, where nothing is forced to be just one thing, and everything is at peace. Take a slow, deep breath in, and let it out with a soft, quiet sigh. As we sit here with these strange ideas of particles choosing paths and waves collapsing into points, remember that you don't need to solve these puzzles tonight. You don't need to visualize the math or fully grasp the mechanics of the subatomic. Just as you don't need to understand the complex internal combustion of an engine to enjoy a peaceful ride home in the backseat of a car, you don't need to master the equations of the universe to rest safely within it. Let your shoulders drop an inch. Let the tension in your jaw dissolve. The quantum world is famously mysterious, even to the people who spend their entire lives studying it. It is a place where our common sense, the logic we use to navigate sidewalks and kitchens, doesn't quite apply. And that is okay. In fact, it is more than okay. It is an invitation to let go of the need for control. In this quiet space, there are no problems to solve and no tests to pass. In the world of the very large, the macro world of falling apples and orbiting planets, everything feels certain. If you throw a ball, the laws of gravity and momentum tell you exactly where it will land. It is predictable. It is a world of will and must. But as we descend into the heart of the atom, that certainty begins to fade like a mist in the morning sun. We move from a world of will
into a world of might. This is perhaps the most significant shift in scientific history. For centuries, we thought that if we just knew enough about the present, we could predict the future with absolute precision.
We thought the universe was like a giant, intricate clock, ticking away according to set, unchangeable rules. But quantum physics tells us a different story. It tells us that at the most fundamental level, the universe is built on the math of chance, not the math of certainty. It isn't that our tools are too weak to see the truth, or that we aren't smart enough to find the answer. It is that the answer itself is often a range of possibilities. In the quantum realm, nature doesn't deal in rigid certainties. It deals in probabilities. It is a quiet, rolling sea of perhaps. Imagine a gentle rain falling on a garden at twilight. You cannot say exactly where a single specific drop will land. You cannot point to a petal and say, that drop will hit here at exactly this moment. But you can say, with great confidence, that the garden will get wet. You can predict the pattern of the rain without knowing the path of every individual droplet. This is how scientists look at the subatomic world. They have traded the rigid ruler of certainty for the soft language of likelihood. It is a shift from the hard yes or no of classical physics to a more graceful, swaying maybe. And there is something deeply peaceful about that. The universe isn't a locked gear. It is a fluid, living thing that keeps its options open until the very last moment. As you drift closer to sleep, you might find that your own thoughts are beginning to follow this quantum logic. They are no longer sharp or directed. They are becoming soft clouds of possibility. One thought drifts into another, not with the force of a collision, but with the gentleness of a ripple on a pond. You are moving away from the world of must and should, and into the quiet, probabilistic world of could. You are safe in this space of uncertainty. You don't need to know where your next thought will land or exactly when the transition to sleep will happen. You can simply trust the probability. You can trust that, just like the particles that make up your very being, you are part of a system that knows how to find its way, even without a map. There is a rhythm to this chance, a hidden order in the way the universe rolls its dice. Think of the subatomic world as a gentle game of chance, a quiet rolling of dice across the velvet of space-time. When we step down into the realm of atoms, the rules we learned in the world of the large begin to soften and fade. In our everyday lives, if you place a book on a nightstand, you know exactly where it is. It doesn't move unless you move it. It doesn't shimmer or fade. It is simply there, exactly where you left it. But in the quantum world, things are not quite so settled. If you were to look for an electron, you would find that it doesn't behave like a tiny book or a small marble. You can never say, with absolute certainty, exactly where that particle is at any given moment. Instead, you can only speak in the language of likelihood. You might say there is a high chance of finding it here, near the center, and a lower chance of finding it further away. It is as if the particle is a secret being kept by the universe, a secret that is only revealed when we finally stop to look. This might sound like a lack of order, but in truth, it is a different kind of harmony. This game of luck follows a very specific set of mathematical rules. To describe this, scientists use something called a wave function. You can imagine the wave function as a shimmering map of possibilities.
It isn't a map of where things are, but a map of where they might be. It is a mathematical whisper that tells us how the universe is likely to behave before it makes up its mind. The person who gave us the key to understanding this map was a physicist named Erwin Schrödinger. In the mid-1920s, he formulated a famous equation that bears his name, the Schrödinger equation.
While the world it describes may seem like a game of chance, the equation itself is incredibly, hauntingly precise. It doesn't tell us exactly what will happen, but it tells us the exact probability of every possible outcome. It provides the script for the dance of the tiny, even if the dancers themselves are a bit elusive. It is a strange comfort to know that even in a world built on luck, there is a perfect structure beneath it all. The Schrödinger equation allows scientists to calculate the behavior of atoms and molecules with a level of accuracy that is almost beyond belief. It is the foundation upon which all our modern understanding of chemistry and physics is built. It is the bridge between the unknown and the known. So, as you lie there, you can imagine the trillions of atoms that make up your pillow, your blankets, and your own body. Each one is a tiny pocket of probability, governed by these elegant, invisible waves. They are not solid points of matter, but rhythmic patterns of perhaps. There is no chaos here, only a deep mathematical grace. The dice are rolling, yes, but they are rolling on a table made of perfect logic. The universe isn't guessing, it is simply exploring all the ways it can exist at once. This map of possibilities, this wave function, doesn't look like a jagged line or sharp edge. It looks more like a soft, glowing haze, a cloud of potential that surrounds every particle in existence. And as we look closer at this haze, we begin to see that an electron is much more than a simple dot of light. It is a presence that fills a space, waiting, breathing, and existing in a state of beautiful, quiet suspension. If you were to close your eyes and try to visualize an atom, you might see a tiny sun with little planets circling around it in perfect, predictable loops. This is the image many of us were taught in school, and it is a helpful way to begin. But as we drift deeper into the quantum world, we find that the reality is much softer, much more fluid than those hard, orbiting lines. Instead of a solid little ball of matter, imagine an electron as a soft, luminous cloud. This isn't a cloud made of water vapor or gas, but a cloud of being. It is a presence that spreads out through space, filling a volume with a gentle, glowing haze. In some areas, this cloud is thick and bright. These are the places where the electron is most likely to be found if we were to look for it. In other areas, the cloud is thin and ghostly, fading away into the distance. This cloud is the physical expression of the wave function. It represents all the places the electron might be at any given moment. But here's the secret that the quantum world whispers to us. The electron isn't just hiding somewhere inside that cloud, waiting for us to find it. Until we look, the electron is the cloud. It doesn't choose just one spot to occupy. It exists in every part of that haze simultaneously. It is here, and it is there, and it is everywhere in between, all at the same time. This state of existing in many places or many conditions at once is what scientists call superposition. It is a word that sounds technical, but its meaning is quite poetic. It suggests that at the most fundamental level, The universe is not made of either/or, but of both/and. A particle is not forced to be in just one position. It is allowed to explore all its possibilities, resting in a state of quiet, unburdened potential. It is a comforting thought to realize that before we interfere, before we try to pin the world down with our measurements and our certainties, nature exists in this field of endless perhaps. Every atom in the world around you, the atoms in the air you breathe, the atoms in the soft fabric of your pillow, is resting in this state of superposition. They are clouds of possibility, vibrating with a gentle, unseen energy. Until the very moment a particle is measured or observed, it remains in this superposition of all its possible states. It doesn't have to be one thing. It can be everything it is capable of being, all at once. It is a harmony of every potential reality, a quiet song of existence that plays out in the tiny spaces between things. As you lie there, you can imagine yourself as a part of this great, shimmering field. You are made of these clouds, these soft mists of possibility that are never truly still, yet always at peace. The universe isn't a collection of hard edges. It is a soft, overlapping tapestry of things that could be and things that are, all woven together in the dark. To help your mind hold on to this idea of superposition without feeling the weight of it, imagine a simple silver coin resting on a smooth wooden table. Picture yourself reaching out and giving that coin a gentle flick. It begins to spin, faster and faster, until it becomes a shimmering silver blur. While that coin is spinning, is it heads? Not exactly. Is it tails? No, not yet. In that moment of motion, the coin is a perfect mixture of both possibilities. It exists in a state where neither answer is wrong, and both are equally true. This is the essence of superposition. In the macro world, the world of tables and coins and heavy blankets, the coin eventually loses its energy and tips over, forced by gravity to choose a single side. But in the quiet, microscopic realm of the quantum, the coin never truly has to land. It can stay in that beautiful, blurred state of both indefinitely, dancing in the dark. As you lie there in the stillness of your room, try to sense the air around you. It feels empty, perhaps, or merely cool against your skin. But within that air, and within the very structure of the bed supporting you, trillions of these quantum coins are spinning. They are not waiting to land. They are simply existing in their most natural state, a state of pure potential. There is a profound peace in this. It means that at the very heart of reality, nothing is rigid. Nothing is forced into a box until the universe requires it. The world is soft, flexible, and filled with a quiet, shimmering uncertainty that allows for everything to exist at once. Scientists have found a way to harness this gentle logic to create something truly remarkable: the quantum computer. In a regular computer, like the one in your phone or on your desk, information is stored in bits that must be either a 1 or a 0, like a coin that has already landed. But a quantum computer uses qubits, which can be both a 1 and a 0 at the exact same time. It is as if the computer is allowed to keep all its coins spinning at once. Because of this, it doesn't have to solve a problem one step at a time. It can explore every possible path,
every possible answer, all in a single, silent moment.
It is a machine that thinks in the language of the universe, the language of and rather than or. This vast processing power, capable of handling mountains of data in the blink of an eye, is only possible because we have learned to listen to the way particles behave when they are left to their own devices. We have learned to respect the superposition, the delicate balance of being everywhere and everything at once. It reminds us that the universe is far more generous than we often give it credit for. It doesn't demand immediate answers. It allows for a long, slow moment of perhaps before anything is decided. And as you drift closer to sleep, you might find that your own mind begins to mimic this quantum grace. Your thoughts may become less like solid objects and more like those spinning coins, soft, blurred, and full of every possibility, resting in the quiet dark of the night. There is no rush to choose a single thought, no need to land on one side or the other. You can simply exist in the blur. Within this blur of possibility, we find one of the most famous stories ever told in science. A story that was never meant to be a literal description of the world, but rather a gentle nudge to our imagination. You may have heard of it, the tale of Schrödinger's cat. It is a thought experiment, a quiet puzzle designed by the physicist Erwin Schrödinger in 1935. As you rest here, imagine a soft, sleeping cat tucked away in a sturdy, imaginary box. Along with the cat, there is a tiny, microscopic device, a single atom that might or might not undergo a quantum change. Now, remember our spinning coin from a moment ago? Until we look at that atom, quantum mechanics tells us it exists in a state of superposition. It has both changed and not changed, both at once. And because the cat's state is tied to that atom, the math suggests something truly strange. Until we open the lid, the cat is also in a state of superposition. In the original version of this riddle, the stakes were quite high. But for our purposes tonight, let us imagine the cat is simply in a state of being both alert and deeply, peacefully asleep. It sounds like a fairy tale, doesn't it? A creature existing in two worlds at the same time. But here is the secret that many people forget. Schrödinger didn't create this story because he believed it was true. In fact, he created it to show how ridiculous he thought the theory was. He wanted to highlight what he called the absurdity of quantum logic when you try to apply it to the large physical world we can see and touch. He was saying, in effect, look, surely a cat cannot be two things at once. There must be something we are missing. He was trying to bridge the gap between the very small and the very large. To him, the idea that a living being could be caught in a quantum blur was a sign that our understanding was incomplete. He used the cat as a symbol of the common sense we all carry, the feeling that the world should be, one way or the other, solid and certain. But as the years have passed, this imaginary cat has become a beloved icon of the unknown. It reminds us that there is a boundary where the rules of the tiny world meet the rules of our own, and we are still learning exactly where that boundary lies. It is a comforting thought, in a way. Even the most brilliant minds in history found these concepts so strange that they had to invent stories about sleeping cats just to wrap their heads around them. So, as you lie there, you don't need to solve the mystery of the box. You don't need to wonder if the cat is awake or asleep. You can simply enjoy the fact that, in the realm of pure thought, both things can be true.
You can be a person who is thinking about science and a person who is drifting into dreams, both at the same time. You can exist in your own state of superposition, a quiet, gentle overlap where the waking world begins to fade and the dream world begins to glow. There is no pressure to open the lid. There is no need to decide. The cat in the box is perfectly safe, resting in its state of infinite possibility, just as you are resting now. The universe is wide enough to hold these contradictions. It is large enough to allow for things that don't quite make sense, and it is kind enough to let us ponder them until our eyes grow heavy and our thoughts become soft. Schrödinger's cat isn't a problem to be solved. It's a reminder to stay humble in the face of nature's wonders. It tells us that our intuition, the common sense that tells us things must be either this or that, is only one way of seeing. Beneath the surface, there is a deeper, more fluid reality where the rules are softer, like the edges of a cloud. Take a long, slow breath and let the image of that imaginary box drift away.
The cat is comfortable, and so are you. We are moving beyond the boxes and the boundaries now, toward a deeper understanding of what it means to look at the world. Because as strange as it is for a cat to be in two states at once, there is an even deeper mystery waiting for us. The mystery of the observer. We are beginning to realize that the simple act of looking, the quiet grace of a single glance, might be the very thing that helps the universe decide what it wants to be. If you let your mind wander to the edge of these ideas, you might find yourself asking a question that once kept even Albert Einstein awake at night. He famously asked, "Does the moon exist only when you look at it?" It sounds like a playful riddle, or perhaps a bit of poetry, but in the realm of the very small, it touches on a profound truth. In our everyday world, we assume that things are just there, solid and unchanging, whether we are watching them or not. You know that your chair's in the same place when you leave the room, and that the stars continue to shine even when the clouds hide them from view. But as we descend into the quantum level, the relationship between the thing being watched and the person doing the watching becomes much more intimate. It is no longer a one-way street. In the world we can see and touch, looking feels like a passive act. You can sit in a gallery and gaze at a painting for hours, and the paint will not move. The canvas will not change its colors because of your attention. But in the world of atoms and subatomic particles, to look at something is to touch it. There is no such thing as a truly silent witness in the quantum world. To observe a particle, we must interact with it in some way. We must shine a light on it, or bounce another particle off it, or use a sensor to detect its presence. And at this incredibly tiny scale, even the gentlest touch is enough to change the outcome. Imagine you are in a completely dark room and you want to find a balloon floating somewhere in the air. To find it, you have a long stick that you wave around. When the stick finally hits the balloon, you know where it is. But the very act of hitting it with the stick sends the balloon flying off in a new direction. You have gained information about where the balloon was, but in doing so, you have changed where the balloon is going. This is the heart of the observer effect. In the laboratory, if a scientist wants to see an electron, they must hit it with a photon, which is a tiny particle of light. But because an electron is so incredibly light and small, that single photon acts like a cue ball hitting a billiard ball. The moment the light hits the electron so that we can see it, the electron is knocked off its path.
The very act of measurement, the simple desire to know, physically alters the reality we are trying to study.
It is as if the universe has a built-in privacy, a layer of soft mist that pulls back when we look, but only at the cost of changing the very thing we were curious about. This realization brings us to a quiet, humbling limit of what we can know. It suggests that we can never be purely objective outsiders looking in on nature. We are always, in some small way, part of the dance. As you lie there in the stillness, you might find a certain peace in this. The universe isn't a cold, clockwork machine that runs regardless of us. It is a place where the act of being present, of noticing, and of measuring actually matters. We are woven into the fabric of the reality we see, but this interaction leads to a deeper, perhaps more mysterious consequence. If every time we look, we nudge the world, it means there are things about the universe that will always remain just slightly out of reach. There are secrets that the universe keeps behind a veil of uncertainty. It isn't because our tools aren't good enough, or because we haven't studied hard enough. It is because the universe itself seems to have a limit on how much information it is willing to give away at any one time. This gentle boundary is what defines the very edges of our knowledge, and it leads us toward a principle that changed the way we think about the nature of reality itself. It reminds us that even in a world of precise math and rigid logic, there is always a small, quiet space for the unknown to rest. In the mid-1920s, a young physicist named Werner Heisenberg was pondering this very limit. He was a man who found great peace in the quiet of nature and the solitude of the mountains. And perhaps it was that appreciation for the vast, open spaces that allowed him to see what others had missed. He realized that the universe isn't just shy about being watched. It actually has a set of internal rules that prevent us from knowing everything about a particle all at once.
This isn't a failure of our equipment or a lack of effort on our part, but a fundamental property of the universe itself. It is known as the Heisenberg uncertainty principle. To understand this, you might imagine a cosmic balance scale. On one side of the scale, we have a particle's position, exactly where it is located in the stillness of space. On the other side, we have its momentum, which is a combination of how fast it is moving and the direction it is headed. Heisenberg discovered a strange, unyielding truth. You can never have both sides of the scale perfectly balanced at the same time. The universe requires a trade-off. If you focus all your attention on finding the exact spot where a particle sits, pinning it down to a single, precise point in the dark, the universe compensates by making its speed and direction a mystery. The more certain you are about the where, the less certain you become about the where to. It is as if the particle becomes a blur of motion the moment you try to trap it in a single location. The very act of narrowing down its position causes its momentum to become wild and unpredictable. Conversely, if you decide to measure exactly how fast the particle is traveling, tracking its graceful arc through the vacuum, you lose the ability to say exactly where it is at any given moment. It becomes a ghost, spread out across a range of possible locations. You might know its rhythm and its energy with perfect clarity, but you lose its place in the world. It exists in a state of beautiful, quiet vagueness. In our everyday lives, we are used to knowing both. We can see a car parked in a driveway and know both its position and that its speed is 0. We can watch a bird gliding through the air
and see both where it is and where it is going. But as we drift deeper into the subatomic realm, those certainties begin to dissolve like mist in the morning sun. The universe begins to whisper that at its heart, precision has a price. The more precisely you know where a particle is, the less you know about where it is going. This is a fundamental fact of our existence. It's a reminder that at the most basic level, the world refuses to be fully pinned down or neatly categorized. It insists on a bit of wiggle room, a bit of blurriness, a bit of inherent mystery. As you rest now, let that thought settle over you like a soft, heavy blanket. There is no need to track every movement or know every destination. There is a profound peace in accepting that some things are meant to be a little bit vague. The universe keeps its own balance, trading a bit of knowledge here for a bit of mystery there, ensuring that there is always a sense of movement and life, even in the deepest stillness of an atom. This uncertainty is not a sign of chaos, but a sign of a world that is far more flexible and fluid than we ever imagined. It is a gentle, shifting dance where the dancers are always just one step ahead of our ability to describe them perfectly. To help your mind hold on to this idea as it wanders toward sleep, imagine for a moment that you are holding a camera. It's an old-fashioned camera, the kind that feels heavy and solid in your hands, with a lens you can turn slowly to find the right focus. You are standing in a quiet garden at twilight, trying to take a picture of a single falling leaf. Think about how that camera works. If you set the shutter to be incredibly fast, a tiny sharp click that lasts only a fraction of a second, you can freeze time itself. You capture the leaf in mid-air, every tiny vein on its surface sharp and clear. You know exactly where that leaf is in relation to the trees and the ground. You have captured its position with perfect clarity. But in that frozen image, the sense of movement is completely gone. Looking at the photo, you can't tell if the leaf was falling straight down, drifting gently to the left, or being caught in a sudden swirling gust of wind. The position is certain, but the speed and direction, the momentum, is a total mystery. Now imagine you change the settings. You decide to leave the shutter open for a long time, allowing the soft evening light to pour into the lens slowly. In this photograph, you don't see a sharp leaf. Instead, you see a beautiful, glowing streak of color. You can see exactly where the leaf has been and where it was heading. You can see the grace of its path and the energy of its descent. But the leaf itself has become a ghost. You can no longer point to a single spot in the air and say, "The leaf is right here." Its position has dissolved into a soft, shimmering haze of motion. In our everyday world, we usually assume this is just a limitation of the camera. We think that if we just had a better lens, a more advanced sensor, or a more steady hand, we could eventually capture both the sharp edges of the leaf and the perfect blur of its flight at the same time. We imagine that with enough technology, we could see everything perfectly. But as we drift deeper into the quiet, microscopic world of the atom, we discover a truth that is far more profound. This blurriness isn't a failure of our tools. It isn't because our microscopes aren't powerful enough, or because our scientists aren't careful enough. It is a fundamental property of the universe itself.
The math that governs the very small tells us that this uncertainty is woven into the very fabric of reality. It is as if the universe refuses to be a collection of static, frozen points. It prefers to be a dance. If you try to pin down the dancer to a single coordinate, the dance disappears. If you watch the rhythm and the flow of the dancer becomes a shimmering cloud of possibility.
This realization changed everything. It meant that at the heart of nature, there is a built-in limit to what can be measured. It is a soft boundary, a gentle reminder that we are part of a system that is constantly moving and shifting. This uncertainty isn't a sign of chaos. It is what allows the world to be flexible and fluid. As you rest now, you might feel the stillness of your own room. But even here, the atoms that make up your pillow and your blankets are participating in this same delicate trade-off. They are not tiny, hard marbles sitting perfectly still in the dark. They are tiny ripples of energy, balancing their place and their movement in a way that allows the world to feel solid and reliable, while remaining fundamentally alive. The universe isn't a machine made of rigid parts. It is a harmonious field where every point is a little bit vague and every movement is a little bit mysterious. There is a deep peace in that. You don't need to have every answer or see every edge clearly. You can simply exist in the flow like a streak of light in a long exposure photograph, moving gracefully through the quiet. Perhaps the most poetic chapter in the story of the quantum world is the one that speaks of connection. If the uncertainty principle showed us that nature is a shimmering, blurry dance, then the concept we are about to explore shows us that the dancers are never truly alone. It is a phenomenon that challenges our very understanding of space and separation, suggesting that the universe is far more intimate than it appears to the naked eye. Imagine two tiny particles born from the same event, like two notes played at the exact same moment on a silver string. In the quiet of the subatomic realm, these particles can become entangled. This is a word scientists use to describe a state where two objects become so deeply linked that they no longer have separate identities. They share a single existence, a single mathematical description, and a single fate. They are, for all intents and purposes, two parts of a single whole, even if they are physically moved apart. In our daily lives, we are used to things being separate and distinct. Your pillow is here, and the wall is there. If you move your pillow, the wall remains unchanged. They are independent. But in the quantum world, entanglement weaves an invisible thread between particles that ignores the boundaries of distance. It is as if you had a pair of magic dice, and you gave one to a friend who traveled to the other side of the world. If you rolled your die and it landed on a 6, your friend's die would instantly, in that very same microsecond, settle on a 6 as well. There is no delay, no waiting for a signal to travel through the air, and no way to break the bond. This is the most famous and perhaps the most beautiful mystery in physics. When two particles are entangled, changing a property of one instantly affects the other, regardless of how much space lies between them. If one particle is measured and found to be spinning upward, its distant partner will immediately be found to be spinning downward. It doesn't matter if they are a few inches apart on a laboratory table or if they are separated by the entire width of the Milky Way galaxy. The connection is instantaneous. Albert Einstein, who spent his life seeking the logical, orderly laws of the universe, found this idea deeply unsettling. He famously called it spooky action at a distance. To him, it seemed impossible that something could happen in one place and affect another place without any time passing for a message to travel between them. It felt like magic or a flaw in the theory. He believed there must be some hidden information we were missing, some secret instructions the particles carried with them. But as the decades passed and our experiments became more refined, we learned that Einstein's spooky action was real. We have tested this connection over and over, sending entangled photons through fiber optic cables and even beaming them down from satellites in orbit. Every time the result is the same. The particles remain synchronized. They whisper to each other across the void in a language that doesn't need words or light or radio waves. As you rest now, let that thought settle over you like a warm blanket. The universe is not just a collection of isolated objects drifting in the dark. At its most fundamental level, it is a web of connections. While the objects in your room seem separate and still, they are built from the same fabric that allows for this incredible, silent unity. There is a profound peace in the idea that nothing is ever truly lost or truly alone. We are part of a system where everything is, in some small and subtle way, linked to everything else. You are resting within a cosmic tapestry where every thread is tucked into another, forming a single, vast, and harmonious whole. It is fascinating to think about how fast the universe truly is. We are taught that light is the ultimate traveler, the fastest thing there is, zipping through the void at a speed we can hardly imagine. It takes light about 8 minutes to journey from the golden surface of the sun to your window. But quantum entanglement seems to do something even more miraculous. It operates in the space between moments, occurring in what scientists call zero time. It is faster than the blink of an eye, faster than a heartbeat, faster than light itself. At first glance, this seems to break the most fundamental rule of the universe, the cosmic speed limit established by Einstein. But there is a gentle logic to it that keeps the world stable and safe. You see, when two particles are entangled, they stop being two separate things. They become a single entity that just happens to occupy two different places at once. Because they are one, they don't need to send a signal back and forth. They don't need to shout across the distance or wait for a message to arrive through the air. Imagine you are holding a long, beautiful ribbon of silk. If you gently tug on one end, the other end moves at the exact same time, no matter how long the ribbon is. There is no delay because the ribbon is a single, continuous object. In the same way, the universe doesn't have to wait for information to travel between entangled particles. The information was already there, woven into their shared identity from the moment they were born together. It is a quiet, profound realization that at the smallest scales, distance is almost an illusion. Two things can be far apart in space, yet perfectly synchronized in their existence. Scientists have gone to great lengths to prove this beautiful connection. They have used powerful lasers and sensitive detectors, stretching these quantum bonds across vast landscapes to see if they would break. They haven't. In recent years, researchers even used a satellite high above the Earth to beam entangled particles to two different ground stations, separated by more than 700 miles. Even across that massive distance, through the atmosphere and the cold darkness of the night, the particles remained perfectly in tune. If one was measured, its partner hundreds of miles away reacted instantly, as if they were still touching. Let that thought bring you a sense of quiet wonder as you lie there, perfectly still. The same laws that govern those distant particles are the laws that govern the atoms within you and the air in your room. You are part of a reality that is far more interconnected than it appears on the surface. We often feel like we are separate, moving through a world of disconnected objects. But science whispers a different story. A story of a universe where everything is secretly holding hands, where the far reaches of space are just as present as the warmth of your pillow. You are resting in a world that is deeply, fundamentally together. There is no gap too wide for the universe to bridge, and no distance that can truly separate the parts of the whole. As you drift closer to sleep, you can let go of the weight of the day, knowing you are a vital part of this vast, synchronized dance. You are supported by a reality that is woven together with threads of light and logic, stretching out across the miles and the years, always connected, always home. As you settle deeper into the stillness, we move from the mystery of connection to a different kind of quiet magic, the ability of nature to do the seemingly impossible. In our everyday lives, we are used to the idea of solid boundaries. If you toss a soft ball against a wall, it bounces back. If you try to walk through a closed door, you find yourself stopped by the firm reality of wood or steel. It is a world of here and there, separated by obstacles that require energy to overcome. But in the world of the very small, the rules of walls and boundaries are not quite so strict. This is a phenomenon known as quantum tunneling. It sounds like something from a dream, the idea of passing through a locked door without ever opening it. But for a subatomic particle, a wall isn't always a dead end. Sometimes it is more like a thin, permeable mist. To understand how this works, think back to the image of the particle as a wave, a gentle ripple of probability moving through space. When this quantum wave encounters a barrier it doesn't have the energy to climb over, it doesn't just stop abruptly like a marble hitting a brick. Instead, a tiny, faint part of that wave, a whisper of possibility, leaks through to the other side. Imagine a soft fog rolling toward a glass window. Most of the fog stays outside, but a few molecules of moisture might find their way through a tiny gap, appearing on the inside as a faint dew. In the quantum world, because the particle is a wave of where it might be, there is always a very small, very real chance that it exists on the other side of the obstacle. And because it can be there, sometimes, it simply is. It doesn't travel through a hole. It doesn't break the barrier. It simply ceases to be on one side and begins to be on the other. This subtle leak is much more than just a curiosity of physics. It is the reason our world is bathed in light and warmth. High above you, in the silent, glowing heart of the sun, atoms are constantly trying to come together to create energy through a process called fusion. But these atoms have the same electric charge, and like the same poles of two magnets pushed together, they repel each other with incredible force. They push and push, trying to stay apart. If the universe followed only the rules of the large-scale world we see with our eyes, the sun would never be hot enough or pressurized enough to force these atoms to touch. The sun would be a cold, dark ball of gas, and the Earth would be a frozen shadow. But because of quantum tunneling, the impossible becomes possible. Every so often, two atoms that should be pushed apart by their own electrical walls manage to bypass the barrier. They don't have enough energy to crash into each other, yet they find themselves on the other side of the repulsion anyway. They tunnel through the invisible wall and fuse together, releasing a tiny spark of energy. When you consider that there are trillions upon trillions of these events happening every single second, those tiny sparks become the roaring furnace of the sun. Without this quiet, quantum miracle, the stars would never have ignited. Every beam of starlight that has ever traveled through the void to reach your eyes, and every bit of warmth that grows the food we eat, is a gift from a particle that decided to walk through a wall. It is a comforting thought to hold as you drift toward sleep, that even the most solid-seeming obstacles in the universe have a way of being overcome. Nature finds a path, not always by force or by climbing over, but sometimes by simply existing in a way that makes the barrier irrelevant. The universe is full of these soft bypasses, where the rigid rules we expect are replaced by a gentle, persistent flow. You can let your mind rest in that same way now, letting go of the obstacles of the day and allowing yourself to simply drift through the quiet spaces of the night. You are supported by a reality where even the sun itself relies on the gentle persistence of the very small. Just as the sun's warmth reaches you through the vast emptiness of space, the very objects you touch right now possess a spaciousness of their own. Take a moment to settle into the surface beneath you. Feel the weight of your shoulders sinking into the mattress, or the way the fabric of your blanket rests against your skin. To our senses, these things are the very definition of solid. They have texture, they have resistance, and they provide a reliable foundation for our rest. But if we were to take a quiet journey into the heart of that material, into the atoms that make up the wood of the bed frame, the cotton of the sheets, or the very cells of your body, we would find something quite startling. We would find that the foundation of our physical world is made almost entirely of nothing at all. This is one of the most beautiful and humbling truths of science. Every object you see is a collection of atoms, and every atom is composed of a tiny, dense nucleus surrounded by a cloud of electrons. But the scale of these parts is nearly impossible to grasp without a gentle comparison. Imagine for a moment that we could enlarge a single atom from your pillow until it was the size of a massive professional sports stadium. If you were to stand right in the center of that stadium, the nucleus of the atom, the part that contains almost all of its mass, would be no larger than a small fly resting on the grass at the 50-yard line. And where would the electrons be in this giant space? They would be like tiny specks of dust, whirling and buzzing around the very highest seats in the bleachers at the furthest edges of the arena. Everything else in that vast stadium, the thousands of empty chairs, the wide open air above the field, the corridors and the stands, would be completely, utterly empty. This is the true architecture of the world around you. More than 99.99% of every atom is just vast, silent, empty space. If you were to take all the people on Earth, all 8 billion of us, and somehow remove all of that empty space from within our atoms, the entire human race would fit inside the volume of a single sugar cube. We feel so substantial, so heavy and present, yet the actual stuff we are made of is spread so thin that we are, in a sense, mostly made of the void. It is a peaceful thought to hold as you drift toward sleep. You are not a heavy, dense object, but a collection of vast, open spaces, held together by the most delicate and rhythmic of laws. You are more like a quiet, star-filled galaxy than a solid stone. There is a lightness to your being that the mind rarely acknowledges, a built-in room for breath and stillness that exists at the very center of every cell. But this realization brings with it a gentle mystery.
If the chair you sit in is almost entirely empty space, and your own body is almost entirely empty space, why don't you simply pass through it? Why doesn't the earth give way beneath us? And why do our hands meet resistance when we touch a table or a wall? If the stadium of the atom is so vacant, why does it feel so firm? The answer is not found in the presence of solid matter, but in a dance of invisible forces that act as a shield, protecting the boundaries of our world and keeping us safely supported in the dark. As you continue to relax, let your mind rest on the idea that even though the world is mostly space, it is a space filled with a powerful, invisible grace that holds everything exactly where it needs to be. Think for a moment about the sensation of your body resting against the mattress. It feels so certain, doesn't it? The weight of your limbs, the way the fabric supports you, and the simple fact that you aren't falling through the bed and into the floor below. We take this solidity for granted, seeing it as the most basic rule of our physical world. But as we have learned, the atoms that make us up are almost entirely empty space. If we are mostly void, and the objects around us are mostly void, then the sensation of touch is one of the most beautiful illusions in all of nature. When you press your hand against a surface, you aren't actually feeling matter meeting matter. In the strict physical sense, the atoms in your hand never truly touch the atoms in the table or the sheets. Instead, you are feeling the invisible repulsion of electron fields. To visualize this, imagine two magnets with their north poles facing each other. As you push them together, you feel a resistance, a strange, invisible springiness that gets stronger the closer you get. You can feel the force, even though there is nothing but air between the magnets. You can push and push, but they refuse to meet. This is exactly what is happening at the tip of your finger right now. Every atom is surrounded by a cloud of electrons, all carrying a negative charge. Because like charges repel, the electrons in your skin and the electrons in your bed are constantly pushing away from one another. You are, in a very real sense, floating. You are hovering a microscopic distance above every surface you have ever touched, held aloft by a cushion of electromagnetic force that never tires and never fails. But there is another, even deeper reason for this feeling of firmness, a principle that acts as the ultimate guardian of the material world. It is known as the Pauli exclusion principle, named after the physicist Wolfgang Pauli. It is a fundamental law that governs the behavior of particles like electrons, which belong to a family called fermions. This law states that no two electrons can occupy the exact same quantum state at the same time. Think of it as the universe's most polite but firm rule of personal space. Every electron demands its own unique address within the fabric of reality. When you try to push two atoms together, their electrons cannot simply merge or overlap into the same space. They resist with a power that far exceeds the strength of their electrical charges alone. This resistance is the true reason the floor feels solid. It is the reason stars don't collapse instantly under their own weight, and the reason you can rest your head on your pillow tonight with total confidence. It is a comforting thought to hold as you drift. Realize that you are being supported by the very laws of logic that hold the universe together. You don't have to do anything to remain held. You don't have to try to stay on top of the world. The universe has written a rule into its very foundation that says, you shall be supported. Take a slow, deep breath and feel that support.
Feel the invisible hands of quantum physics holding you steady. You are resting on a bed of light and force, a stable platform built from the tiny, rhythmic pulses of the subatomic world. Even in the silence and the darkness, these forces are awake, working tirelessly to provide the structure and the safety you need to let go. The world is not a collection of hard, cold stones, but a tapestry of energetic fields that dance and repel and connect in perfect harmony. And as we look closer at these tiny dancers, we find they have even more secrets to share, hidden qualities that define how they move and how they talk to one another across the vastness of space. One of those secrets is a strange internal rhythm, a quiet pulse that scientists call spin. As you settle deeper into the quiet of your room, consider that every single particle that makes you who you are possesses a hidden quality, a secret rhythm known as spin. It is a word that sounds familiar, perhaps bringing to mind a child's toy top whirling on a wooden floor, or the slow, majestic rotation of the earth as it turns away from the sun to bring us the night. But in the realm of the very small, spin is something far more mysterious and elegant. When physicists first glimpsed this property, they naturally imagined the electron as a tiny, solid ball rotating on an axis. But as we have learned, the quantum world rarely follows the rules of our everyday experience. An electron does not have a physical surface that can be touched, and it is not literally spinning in space like a planet. Instead, spin is an intrinsic form of energy, a permanent part of what a particle is. It is more like an internal compass that every particle carries within its heart. Think of it as a quiet, steady pulse that never fades. This spin gives particles a magnetic personality. Because of this internal rhythm, every electron acts like a microscopic magnet with a north and a south pole. This is why we say an electron can have a spin that is up or down. There is no middle ground, no slowing down, and no stopping. Even in the deepest chill of outer space, or in the perfect stillness of your own rest, the particles within you maintain this constant, rhythmic orientation. It is a fundamental signature of existence, a tiny, unwavering light in the dark. This isn't just a curiosity for textbooks or a puzzle for mathematicians. This invisible spin is the reason we can see inside the human body with breathtaking clarity without ever making a single incision. If you have ever seen an MRI machine or heard its rhythmic, thumping song, you have witnessed the power of quantum spin in action. The M in MRI stands for magnetic, and the R stands for resonance. The machine uses a powerful magnetic field to gently persuade the spins of the hydrogen atoms in your body, mostly found in the water that makes up so much of your physical self, to align.
like a vast field of tiny compass needles all suddenly turning to face the same north. Your atoms respond to the call of the magnet. Then, the machine sends a soft pulse of radio waves that tips those spins over. When the pulse stops, the atoms relax and snap back to their original alignment. As they do, they release a faint, ghostly signal, a tiny whisper of energy. The MRI machine listens to these billions of tiny whispers, using the timing and strength of the signals to map out the soft tissues of your brain, your heart, or your muscles. It is a profound thought to hold as you drift toward sleep. Your very stillness allows a machine to hear the secret language of your particles.
Even as you lie here, quiet and unmoving, the atoms within you are engaged in this constant, rhythmic dance of orientation. They are never truly off. They are always part of a grand, organized system that keeps your body functioning and the world around you stable. This strange, abstract science is not far away in a lab. It is right here, in the very fabric of your breath and the structure of your cells. And as we realize how this secret language of particles helps us understand our own bodies, we begin to see that quantum physics isn't just a theory for the stars or the distant reaches of the universe. It is the silent engine behind almost every piece of technology you touch throughout your day, providing a bridge between the mysterious world of the atom and the familiar comforts of your modern life. It is perhaps one of the most beautiful ironies of our modern age that the theories which seem the most distant from our common sense are the very ones that power our most familiar comforts. We often think of quantum physics as a realm of high-tech laboratories, giant particle accelerators, and complex equations scribbled on chalkboards. It feels like a science of the elsewhere, a set of rules for a world we can never truly touch. But as you lay here, perhaps with your smartphone resting on a nightstand or a laptop cooling nearby, you are closer to the quantum world than you might imagine. This strange science is actually very practical, and it is tucked away in your pocket, your car, and your home, working silently while you rest. The modern world is built on the shoulders of these tiny particles. If we were to suddenly lose our understanding of quantum mechanics, our entire digital civilization would go dark. Every smartphone, every computer, and every digital watch relies on the behavior of electrons that can only be explained through the quantum lens. At the very heart of all these devices is a tiny, unassuming component called the transistor. You can think of a transistor as a gatekeeper. It is a small switch that can either allow electricity to flow or block it entirely. In the early days of electronics, these switches were large, glowing vacuum tubes that were fragile and generated a great deal of heat. But quantum physics allowed us to create something much smaller and more elegant. The transistor works because of a quantum phenomenon called band theory. In certain materials, like silicon, electrons are only allowed to exist in specific energy levels, much like the steps of the ladder we spoke of earlier. By carefully adding tiny amounts of other elements to the silicon, scientists can create a material where the movement of electrons can be controlled with incredible precision. This is the birth of the semiconductor. Because of quantum mechanics, we can pack billions of these tiny gates onto a chip no larger than your fingernail. Every time you send a text, save a photo, or scroll through a page, billions of quantum gates are opening and closing in a rhythmic, invisible dance.
Even the way we find our way through the world is a gift of the quantum realm. The Global Positioning System, or GPS, that guides us through unfamiliar streets, depends on the extreme precision of time. Satellites orbiting high above the Earth carry atomic clocks, which are the most accurate timekeeping devices ever created. These clocks don't use gears or springs. They measure the steady, unwavering ticks of atoms as they jump between energy levels. This is a purely quantum process, as reliable as the spinning of the Earth itself. Without this quantum precision, the timing of the satellites would drift by tiny fractions of a second, and within a single day, the GPS on your phone would be off by several miles. It is a comforting thought to realize that the universe's strangest rules are also its most reliable. The same laws that allow a particle to be in two places at once are the ones that ensure your alarm goes off at the right time and your messages reach your loved ones across the globe. As you settle deeper into your pillows, let the thought of this invisible, orderly technology bring you a sense of security. The world is not just a collection of random events. It is a finely tuned system, governed by laws that work perfectly, even when we aren't looking. This science is not a mystery to be feared, but a quiet, constant companion that makes our modern life possible.
And as we look at how these particles move through the wires and chips of our devices, we can also look at how they create the very light that helps us see the world around us. For just as the electron powers our computers, the movement of light itself holds its own quantum secrets, waiting to be gently uncovered. Perhaps one of the most beautiful expressions of these secrets is found in the light of a laser. When we think of a laser, we might imagine a thin, glowing line of red or green light, reaching out across a dark room with perfect stillness. Unlike the light from a lamp or the sun, which spreads out in every direction to fill a space, the light of a laser is remarkably disciplined. It is a concentrated stream of photons, all moving in the exact same direction, at the exact same frequency, in perfect harmony. In a standard light bulb, atoms release their light at random intervals, like a large crowd of people all speaking at different times and in different tones. This creates a soft, scattered glow. But a laser works through a process known as stimulated emission. Imagine an atom that has been given a little bit of extra energy. It is in an excited state, waiting for a reason to let that energy go. If a photon of a specific color passes by this atom, it gently stimulates it, encouraging the atom to release its own photon. The wonderful part of this quantum interaction is that the new photon is an exact twin of the first one. They have the same energy, the same color, and they travel in the same direction, perfectly in step with one another. This process repeats over and over, with one photon inviting another to join the dance, until you have a vast choir of light, all singing the same note. This is why laser light is so pure in color. While white light is a mixture of many different wavelengths, a laser is a single, unwavering frequency. It is the visual equivalent of a single, clear bell ringing in the silence. Because these photons are so well organized, the beam does not spread out like a flashlight beam would. It stays narrow and powerful, even over long distances. We see this precision in many parts of our lives, often in ways we don't even notice. When you are at the grocery store and the clerk passes an item over a scanner, a tiny low-power laser is reading the patterns of the barcode with incredible speed and reliability. In the hands of a doctor, a laser becomes a tool of profound healing. It can be used in delicate eye surgeries to repair tissue with a level of accuracy that a physical blade could never achieve, working with a touch so light it is measured in the width of a single cell. This is the beauty of quantum mechanics in practice, taking the strange behavior of the very small and using it to bring clarity and health to our world. It is fascinating to think that this sophisticated technology is simply a way of organizing the natural behavior of light.
We have taken the quantum rules that govern how atoms and energy interact and organized them into a focused beam. But as we move from the tools in our pockets and the lights in our clinics, we begin to see that these rules aren't just for our inventions. They are the same rules that define the structure of everything in the cosmos. The laser shows us how particles of light, or bosons, can behave when they are in unison. But light is just one part of a much larger family. Beyond the glow of the laser and the hum of the transistor, there is a whole alphabet of particles that build the stars, the air, and the very hands you use to pull your blankets closer. As we drift further into the quiet of the night, we can begin to look at this fundamental family tree, the tiny building blocks that make up the entire story of the universe. If you look at the world around you, it seems impossibly complex. You see the vast diversity of the trees, the shifting colors of the sky, the depth of the oceans, and the intricate patterns of every living thing. It feels as though there must be an infinite number of ingredients required to build such a magnificent reality. But when we look closer, through the lens of quantum physics, we find something far more elegant and simple. Scientists have discovered that everything we see, touch, and experience is written in a very short alphabet. It is a quiet, fundamental language that we call the Standard Model. Think of this model as a family tree, or a collection of characters in an ancient, peaceful story. While the universe is vast, it is built from just 17 fundamental particles. These 17 building blocks are all that is needed to weave the entire tapestry of existence. They are the smallest letters in the alphabet of the universe, and they never rest, even as you find your own moment of stillness tonight. Within this small family, there are different groups, each with its own role to play. First, there are the quarks. These are the social particles, the ones that love to be together. You will never find a quark wandering alone. They are always bound to one another in groups of 2 or 3. There are 6 types of quarks in total, with names that sound almost like a gentle poem: up and down, charm and strange, top and bottom. The up and down quarks are the ones that matter most to our daily lives, as they join together to form the protons and neutrons inside every atom in your body. It is a comforting thought to realize that the core of your being is held together by these tiny, inseparable companions. Then we have the leptons. There are 6 of these as well. The most famous lepton is the electron, the tiny point of light and energy that we have talked about so often. But there are also the neutrinos, particles so light and ghostly that they can pass through miles of solid lead and through us without ever touching a single thing. Millions of them are drifting through the room right now, as silent and unnoticed as a dream, moving in a graceful, endless stream from the heart of the sun. Finally, there are the bosons. If the quarks and leptons are the characters of the story, the bosons are the storytellers. They are the messengers that carry forces between the other particles. We have already met the photon,
the messenger of light. Then there is the gluon, which acts like a powerful, invisible glue to keep the quarks nestled tightly together. And perhaps most famous of all is the Higgs boson, often called the particle that gives mass to everything else. It is like a quiet field of snow that everything must move through, giving weight and substance to the world so that it doesn't simply fly apart. 17 particles. It is a remarkably small number of ingredients for such a grand and beautiful recipe. Every star in the night sky, every blade of grass, and every breath you take is just a different arrangement of these same 17 notes. It is a rhythmic, repeating harmony that underlies all of nature. As you lie there, you might imagine these particles as tiny, vibrating points of light, all working in perfect, silent unison to create the bed you rest on and the air you breathe. There is a deep peace in this simplicity. We often feel overwhelmed by the complexity of life, but the universe itself is built on a foundation of order and economy. It uses the same few pieces over and over again, crafting a world of infinite variety from a handful of simple truths. This family tree of particles is the quiet architecture of the cosmos, a structure that remains steady and reliable, whether we are awake to observe it or drifting off into a deep, restorative sleep. Even though we have mapped out these 17 characters, the story is far from finished. Knowing the names of the particles is like knowing the names of the stars. It doesn't take away from the wonder of looking up at the night sky. In fact, the more we learn about the alphabet, the more we realize how mysterious the book truly is. There are still many things we do not know, and in the world of the very small, mystery is not something to be feared. It is simply a part of the beauty. Scientists, even those who have spent their entire lives studying these 17 particles, still find themselves standing in awe of how they behave. As we move closer to the edge of what is known, we find that the most profound wisdom often comes from simply accepting that the universe is far more wonderful than our logic can always grasp. As we sit with these thoughts, it is important to remember that you do not need to hold on to every detail. The beauty of quantum physics isn't found in memorizing equations or mastering the math. It is found in the mystery itself, in the quiet realization that the universe is far more expansive and imaginative than we ever could have dreamed. There is a deep, restful comfort in acknowledging that we don't have all the answers. In our daily lives, we are often expected to be certain, to be logical, and to understand exactly how the world works. But at the very heart of reality, nature seems to whisper that it is okay to be uncertain. It is okay to simply wonder. Even the most brilliant minds, the people who dedicated their lives to uncovering these secrets, found the quantum world to be deeply, wonderfully weird. They didn't see this weirdness as a problem to be fixed, but as a fundamental truth to be embraced. Albert Einstein, Niels Bohr, Werner Heisenberg, these were men of immense intellect, yet they spent decades debating and marveling at how strange these rules were. They struggled with the idea that a particle could be in two places at once, or that the act of looking at something could change its behavior. It challenged everything they thought they knew about the world. There is a profound relief in letting go of the need to solve the puzzle. You are not meant to carry the weight of the universe's logic on your shoulders tonight. You are simply here to witness it. Richard Feynman, one of the most beloved and brilliant physicists of the 20th century,
was famous for his honesty about this. He was a man who won the Nobel Prize for his work in quantum electrodynamics, yet he remained humble in the face of the unknown. He once said, quite simply, "If you think you understand quantum mechanics, you don't understand quantum mechanics." He didn't say this to discourage people or to make the subject seem impossible. He said it to set us free.
He wanted us to understand that even the experts are, in a way, like children looking up at the stars, full of awe and aware that the reality we inhabit is much larger than our ability to describe it. When you stop trying to force the quantum world to make sense according to the rules of your kitchen or your office, a new kind of peace settles in. You allow yourself to exist in a universe that is poetic rather than just mechanical. The unknown is not a dark or scary place. In the context of quantum science, it is a soft, quiet space where anything is possible. It is a reminder that there is always more to discover, more to feel, and more to appreciate in the silent workings of the world around us. This weirdness is what allows the sun to shine and your heart to beat. It is the secret rhythm of the cosmos. As your mind drifts, let these mysteries become like a gentle fog, obscuring the hard edges of the day and allowing you to sink deeper into the stillness. You don't need to bridge the gap between the tiny world of the atom and the large world of your room. You can simply exist in both. You are a part of this mystery, a collection of trillions of particles that are all following these strange, beautiful, and invisible rules. There is no requirement to understand the why or the how right now. The universe is functioning perfectly well without our constant supervision. It is holding itself together with a quiet grace, weaving waves and particles into the solid reality you feel beneath you. As we move closer to sleep, we can appreciate that the most profound wisdom often comes from simply accepting that the universe is far more wonderful than our logic can always grasp. Like a vast, dark ocean, the quantum world has depths we cannot see, and that is what makes it so majestic. It is a grand, silent tapestry, and we are just beginning to see how the threads are woven together. In this space of not knowing, there is a perfect, enduring stillness. You can let go of the day, let go of the questions, and simply be a part of the beautiful, unknown whole. Imagine all these threads we have discussed over our journey. The tiny bundles of energy called quanta, the shifting waves of probability, the invisible connections of entanglement, and the sudden, miraculous leaps of tunneling. Individually, these concepts might seem strange, perhaps even impossible. But as we step back, moving from the microscopic to the familiar world of your room, we see that they are not separate or chaotic events. They are the individual threads of a vast cosmic tapestry. This tapestry is everything you have ever known: the air you breathe, the soft weight of your blanket, and the distant, ancient light of the stars. It is a single, unbroken work of art that is constantly being woven in the silence of the subatomic. While the quantum world is a place of constant motion and change, the reality it creates for us is remarkably stable and quiet. It is a beautiful paradox. Deep down, at the very foundation of matter, everything is vibrating and dancing in a state of flux. Yet here you are, resting in a space that feels solid, secure, and permanent. The floor beneath you is steady. The air in the room is still. Your breath is a slow, rhythmic cycle that requires no effort. This stability is the result of billions upon billions of quantum interactions settling into a state of perfect harmony. It is as if 1 trillion tiny voices are singing in unison to create one soft, low hum that supports the entire world. As you lie there, you might try to visualize this field of energy. It isn't a void or an empty darkness. It is a rich, invisible landscape that connects every point in space to every other point.
In physics, we often speak of fields, the gravitational field that holds you gently to the earth, or the electromagnetic field that carries light to your eyes. Modern science suggests that at its core, the universe is a harmonious field of energy. This field is the fundamental fabric of existence. It is always there, even in the deepest dark, even in the most profound silence. It is a gentle sea of potential that never truly stops, providing the stage upon which the story of the universe is written. Feel the weight of your body as it rests upon this field. You are not a visitor in this universe. You are a part of its very structure. Every atom in your body is a note in this grand, silent composition. The same laws that govern the furthest spinning galaxy are governing the quiet, internal movement of your cells. There is a profound sense of order within the mystery. The quantum world provides the energy and the infinite possibilities, while the world we see provides the form and the peace. Together, they create a home for us, a place where we can wander and where, eventually, we can find a deep and natural rest. The tapestry is complete, and it is holding you safely. You don't need to hold on to the thoughts of the day anymore. You don't need to keep track of the logic or the details. The energy of the universe is steady and balanced. Like a lake that has become perfectly still after the wind has died down, the ripples of your thoughts are beginning to smooth out. The connections are all in place. The waves have found their rhythm. You are part of a stable, beautiful reality that is much larger and more enduring than any single worry. Take a slow, deep breath and simply feel that harmony. It is a quiet strength that exists in every corner of space and every cell of your being. This is the quiet truth of the world, that beneath the surface of the strange and the small, there is a deep, underlying unity. Everything is connected. Everything is part of the same energy. And everything, in this moment, is exactly as it should be. As we reach the quiet conclusion of our journey through the very small, let your mind drift like a particle on a gentle, slow-moving current. There is no more information to process, no more mysteries to solve, and no more logic to hold on to. You have traveled from the scale of your own room down to the vibrating strings of reality, and now it is time to return to the simple, physical presence of your own rest. Your body is a magnificent collection of all the wonders we have discussed tonight. Within you, trillions of atoms are performing their quiet, eternal dance. Their electrons are occupying those soft clouds of possibility, and their nuclei are held together by the strongest, most reliable forces in the universe. You are not just a person lying in a room. You are a living, breathing testament to the harmony of the quantum world. In the stillness of the dark, the boundaries between you and the universe feel a little softer, a little less defined.
You are supported by the same fundamental fields that guide the light of the most distant stars. You are cradled by the same laws that keep the sun burning and the atoms of your bed solid beneath you. It is a comforting thought to know that even as you let go of conscious thought, the universe continues its steady, rhythmic work. Your heart follows its own internal beat. Your lungs expand and contract with the grace of a slow tide, and your mind begins to shift its frequency. It is a beautiful fact of our existence that sleep itself is a biological rhythm, a cycle that is as steady and fundamental as a quantum wave. Just as an electron moves through its energy states with mathematical precision, your brain waves are now slowing, lengthening, and finding a new, peaceful resonance. You are transitioning from the frantic, high-frequency particles of the waking day into the long, smooth, and undulating waves of deep rest. This is your natural state, to return to the quiet energy from which everything is built. Think of your consciousness now as a wave function that is gently expanding, filling the room with a sense of profound peace. There is no need to observe or to measure anything anymore. In the world of the tiny, we learned that the act of looking changes the result. But now you can close your eyes and let the world exist without your supervision. Without the pressure of the observer, the universe can simply be. You can simply be. The particles of your worries have dissolved into a sea of probability, and the most probable outcome tonight is a deep, restorative, and uninterrupted slumber. The quantum sea is vast, but it is also warm and familiar. It is the source of everything you are and everything you will ever be. As the light of your thoughts fades to a soft, dim glow, remember that you are never truly alone in the dark. You are part of a grand, interconnected tapestry that stretches across the infinite. Every atom in your pillow, every molecule of the air you breathe, and every cell in your resting form is part of the same beautiful, unified story. The universe is a quiet, stable home, and it is holding you safely in its arms. Let the silence of the subatomic world lull you now. Feel the gentle weight of your limbs, the softness of your breath, and the steady, rhythmic pull of the earth. You have learned the secrets of the small, and now you can embrace the peace of the great. There is nothing left to do but drift. The waves are calm. The energy is balanced. The world is at rest. Sleep now, and let the quiet wonders of the quantum world watch over your dreams. Good night and peaceful journeys.